When we think of things that release carbon dioxide into the atmosphere, we often think cars and factories. But a huge emitter of CO2 that's often overlooked is cement.
Cement is kind of the glue that holds concrete together. And concrete is used more than any other material on the planet other than water.
Concrete is used to build our bridges, our dams, our roads, our sidewalks, even our skyscrapers. This material has helped us build civilizations, but it has also strained our environment in the process. And most of that strain is due to the production of cement, a key ingredient in concrete. For every 1 ton of cement produced, there is a ton of CO2 that is released into the atmosphere. Every year, more than 4 billion tons of cement are produced, accounting for around 8% of global CO2 emissions. To put that in context, if the cement industry were a country, it would be the 3rd largest emitter of CO2 in the world. Atmospheric CO2 levels are directly correlated with rising global temperatures, and both have been rising drastically. If the planet's temperature gets too warm, climate scientists predict bouts of extreme weather, rising sea levels, and scarce food supplies. One company working to reduce the carbon footprint of cement is New Jersey-based startup Solidia Technologies. Solidia says their cement mixture and curing process can cut CO2 emissions by up to 70%. But even if Solidia's technology works, it still faces a major challenge: convincing conventional cement and concrete makers to use it.
Right now, there just aren't a lot of people asking for lower carbon concrete or are willing to pay a premium if there is.
To understand the mechanics of how Solidia's technology works, it's important to first understand the difference between cement and concrete and the conventional process for making each. Cement is usually composed of a mixture of limestone and clay and is one of the ingredients in concrete, along with water, sand, and gravel. The most widely used cement today is known as Portland cement.
Most of the emissions associated with concrete actually occur in the production of the cement. The way that you generally make cement is you mine limestone from the earth, and then you mix it with some other things and heat it up in a kiln to very high temperatures, about 1500 degrees Celsius. Then there's a chemical transformation that takes place, and there's carbon dioxide that's emitted as part of that chemical transformation, and also carbon dioxide emitted with the energy associated with heating up the kiln in which the cement is produced to such high temperatures.
What comes out of the kiln is a substance known as clinker, which is then cooled, ground, and mixed in with limestone to create cement. In order to reduce the carbon footprint of its cement, Solidia Technologies had to slightly alter the chemistry of the mixture. But the process and equipment needed remains largely unchanged.
In order to make Portland cement, you use limestone and sand, you mix it about 2/3, 1/3, and you put it into a kiln that reacts at about 1500 degrees Celsius, so really hot. We take exactly the same raw materials, but we change the recipe a little bit. We mix it about 50-50, and that reaction happens at a much lower temperature, about 1200 degrees Celsius. Now, what that means to the cement company is instead of emitting 1 ton of CO2 for every ton of cement, they emit about 40% less than that, and they use 30% less energy to make that same amount of cement. They also get more cement with the same amount of raw materials.
Solidia cement also cures or hardens into concrete differently than Portland cement, reacting with CO2 that the company injects into a drying chamber instead of with water. As the cement hardens, the CO2 becomes trapped in the final concrete product.
When you make Solidia cement, we are cutting the CO2 emissions at least by 30%. And when we cure Solidia cement, when we make the concrete, we add an additional 20-30% of CO2. We consume it during curing. So this adds up to 50-60%, and depending on the formulations, our CO2 savings can go up to 70%.
Another benefit? Solidia helps with water conservation.
The concrete industry uses about 3 trillion liters of water a year. That's about 1 million Olympic swimming pools. Solidia's technology doesn't consume any water, so especially for water-starved areas, India, China, Southern California, we give them the option to be able to recycle their water. When we talk to people in the Mideast, that's actually the #1 thing they want to talk about is water reclaim.
Solidia Technologies also says its product makes financial sense.
We actually find that both on the cement side and the concrete side, if you use our technology, you actually end up saving money. Most of the cost associated with manufacturing cement is in the energy that you use, and we actually reduce that by about 30%, in addition to not having to use a lot of expensive raw materials that they use today. On the concrete side, they don't have a CO2 problem. They don't have a CO2 fee that's going to come attack them. So it really is about performance. And so for us, it's better colors. It's the ability to process it more readily. It's more durable. And I can, instead of curing it in a week or 2 weeks or 3 weeks, it takes us 24 hours. So it's a lot easier for them to get it out in the market. So in the end, we actually are going to save the industry money.
But despite all of this, experts say that there are significant obstacles for Solidia's technology going forward.
Right now, the Solidia product can only be made in a controlled environment. And so as a consequence, they can only make blocks, whereas the vast majority of concrete is ready-mix concrete. And that's what we see in the trucks that are driving around.
Ready-mix concrete accounts for nearly 3/4 of all concrete used. So if Solidia technology is to go mainstream, it needs to find a way to make ready-mix without the need for a strictly controlled environment. It's a problem that Solidia says it's already working to solve.
We're just getting into the market right now. We're doing test pours all around the country and quite frankly in Europe as well. So we're hoping within the next year you'll see us in the ready-mix market as well.
Another big hurdle is code regulations.
This cylinder right here will go into the lab and they'll put a couple 100,000 pounds of force on it, crush it until it breaks, and measure the load, and that gives us a pretty good indication of the performance of that particular concrete mix.
We have to make sure as a company that our technology is validated. It's a 2,000-year-old industry. They really haven't had a new product in a couple of 100 years. So you've got to make sure that industry standards recognize the performance and validate that. So we're working with the Federal Highway Administration in the US, that's DOT. They kind of do the screening for the DOTs, and we're working with several state DOTs to validate the technology with them. But we also work with universities like Purdue, with South Florida, Oregon State, that will take our product and test it under standard testing conditions. But we have to test everything by third parties because nobody's going to believe our data.
One of Solidia's earliest partners and investors is LafargeHolcim, the largest maker of building materials in the world. Earlier this year, the two companies announced that they would be supplying EP Henry, a New Jersey-based precast concrete manufacturer, with Solidia cement.
Our biggest challenge is this will be a structural material, so it has to pass through certain codes, you have to get certified, and this is a long process. So initially we chose products that doesn't really require very intensive code or regulations, so that's why we picked pavers and blocks. They are easiest to the market.
Solidia Technologies is not alone in trying to reduce the carbon footprint of cement. In fact, the green cement market is expected to grow significantly from $21 billion in 2018 to $43 billion by 2026. Other companies working on green cement technology include Blue Planet, CarbonCure, and Carbocrete. Unlike Solidia Technologies, Carbocrete does away with the need for cement and concrete altogether by replacing it with steel slag, a byproduct of steelmaking. This new mix is poured into molds like conventional concrete and cured with CO2. And it's not just companies taking up the call to action. Academics are weighing in too. Despite all their work with perfecting the cement formula, Solidia says it's not trying to become a concrete maker.
Our mission as a company is to help others reduce their footprint. There are plenty of people that do a great job making cement. There are plenty of people that do a great job making concrete. Us adding capacity to that actually will slow down the process because you need a lot of money to spread this all around the world. So we're really focused on helping them transition to this new technology because we think that's going to be the fastest way to get us into the market.
If Solidia Technologies is able to convince the major players in the multi-billion-dollar cement and concrete market to use its technology, it could have a significant impact on our environment. The company says global adoption of Solidia products would reduce CO2 emissions by 4% per year. That is double the CO2 savings that we would get if we grounded the entire aviation industry. Solidia also says it would reduce energy consumption by as much as 260 million barrels of oil and save 3 trillion liters of fresh water per year.
We know that Solidia is scalable because we've already worked with the largest cement company in the world, LafargeHolcim, to help us basically prove that they can make our cement anywhere in the world on any existing kiln with the raw materials they have today. So we know we can do it on the cement side. On the concrete side, we're not changing their mixing process, we're not changing how they put it into a mold or a form, we're just changing the way that it reacts. Instead of putting water in, we put CO2 in. So we have to make a little bit of a change there, but not enough so that it really disrupts their current operating process. So we feel pretty good about the ability to scale it.